So in this question, we've got Spider Guy with a big web blob whipping around in a circle. And it's whipping around the web blob at like 8.2 meters per second. And it's going around one time in 2.7 seconds, actually. So if it goes around once in 2.7 seconds, that is actually what we would call the period of the motion. And we're going to look for the length of the web that he's actually using. All right, well, let's see if we can piece a few things together. Well, first of all, I can't just find mg, I can't find mv squared over r because I don't have the mass, but we'll see what else we can do here. I know this thing's at an angle, okay, and the angle, it's at an angle because there's a couple forces acting on it. First of all, there is a force of gravity obviously going down, and there's also an FC going sideways. And those two forces acting on it actually create the angle that is right there. Okay, so that is probably going to come in handy. Now I also know the radius of the path is down here and also shares the exact same angle with the length of the web, which is what I'm actually looking for. So let's see if all these things can help me out here. Okay, well, first of all, I can try and see if I can put the forces together with the angle. Now this is similar to a carnival ride that we had a few videos ago. Same type of thing. So I got the little forces thing, so I got the trig function. So I've looked at my angle is. Opposite to the angle is my FG, and adjacent is my FC, and they're just making a little right triangle. So if I just start with that, see if that leads me somewhere. Tan theta would be FG divided by FC, which of course is mg divided by mv squared over r. And of course the masses cancel out, which is kind of neat. And I'd be left with gr divided by v squared. Now I'll see if that helps you. Well, I know what my g value is. I don't know my radius, but I do have my speed. But tan theta, no radius, that sort of, I'm a little stuck here. Well, let's see what else we can do. Maybe I can work with that period a little bit. Let's see, period is just the time to go around. Well, I know the time to go around, but I also know how fast it's going. Well, if I have the period and I have the speed, that's just time and speed. Well, time and speed can give me distance. And of course, distance around the circle would sort of connect to the radius. So let's see if that helps me out. Well, if I go back to my basic speed expressions, basic speed expression, of course, is 2 pi rf, or also 2 pi r divided by the period. And of course, you could have just used the period to find the frequency if you wanted to. It doesn't matter. Well, I've got my v, I've got my period, I can calculate my radius. So if I just rearrange this and calculate my radius, I get a radius of about 3.53 meters. I can then use that in here. I'd have my g value, I'd have my r value, just found that, and I know my v, and with that I can then find my angle. So if I put that value in there, multiply at the top, divide by v squared, inverse tan it to get the angle, I will get an angle of, looks like around 27 degrees. Well, now that I have the angle for the forces, which is also the angle used for the radius and the length, they share that angle, I can now calculate the length of the web because it's just a right triangle using the radius and the 27 degrees. So the length of the web would just be the radius divided by cos theta, and I just found that. So I know my radius is 3.53, the web's going to be a little bit longer than that, and if I punch it out, I get a web length around 4.0 meters. Okay, so that would be the length of the web going around the circle.